So we have Don Newell here, Server CTO at AMD. Don, I know that you've had a distinguished career and a lot of success. What do you contribute or attribute your success to? What are the keys to your success?
Oh, you know, people sometimes think success comes from, you know, all individual sorts of capability, achievement, etc. Not true. In my case, a huge amount of my success was making sure that I had a team that was amazingly dedicated at Intel, and then here at AMD, I've actually had, you know, already a pretty good time working at AMD. Had what I think has been a pretty successful first year, and a lot of that has come once again from finding the right people to work with to help, you know, sort of support the parts where I'm weak. So big part of success really is having the right team surround you. The other part is putting a lot of effort into understanding the domains that you're trying to explore. At Intel, for example, we explored everything from networking architectures to cache architectures and a lot of stuff in between. It meant that you had to ramp up on new technologies all the time. You had to be unafraid to spend lots of time learning what other people had already kind of discovered, and then figuring out where your leverage points were to build on top of that. So it's...
Yeah. Well, you know, a lot has changed, obviously, over the years, and especially through your career.
Yeah.
And what lessons do you think that you've learned as far as the journey to the position that you're in now?
Well, you're going to be wrong sometimes, and if you can't swallow that, if you don't have a way to just, you know, sort of internalize, yeah, you know, I made the wrong bet, then you know, you ought not to be in this position. Another thing is, you know, really the kind of capability of allowing others to inform you is key to being able to actually take advantage of any of the opportunities that are sort of lying there. You're not going to see them all yourself. People will help point them out. You got to listen. So.
Excellent. Obviously, the focus of this show is cloud computing, and it seems to be centered around infrastructure, platform, software as a service. Where do you see after that step? Where do you see cloud computing going? What's the future like?
So, you know, there's going to be a progression of how those services are delivered over the next few years. One part where we think we're going to play an important role that ought to be interesting, I think, to the HPC sort of community is that you know, we believe that the era of heterogeneous compute really is upon us, and that's going to evidence itself in the cloud as well. There are a number of workloads that we think will be tractable to GPU compute with that compute on die, right? So an x86 core right next on the same die to a GPU with the GPU actually living inside the same virtual memory as the application that uses it, with all of the sorts of performance efficiencies that gets you, and with the right set of runtime libraries, etc., so that you can have user level scheduling, etc., so that you can do things like context switches through the GPU. All of those pieces coming together will allow mainstream programmers to develop GPU compute programs in ways that are just not possible today. Both, you know, not possible for technical reasons that, you know, most of the algorithms developed using GPU compute have been developed with the expectation that it was off on a PCI Express soda straw. Now it's going to be on die with all the performance efficiencies that sort of gives you. It'll allow you to do nested parallelism in ways that you've never been able to find before. It'll allow you to do fine-grained parallelism in ways you've never been able to do before. So all of that is going to sort of change the nature of what kind of compute resources are available in the data center. Now, if you're talking about the services themselves and how they get delivered, the expectation that I have is many of the sort of obstacles that are preventing essentially that hockey stick of adoption from happening are really around things like security, interoperability, and what people perceive as potential reliability, stability problems. And I think all of those are going to be addressed over the next 4 or 5 years, so that way more people will be able to take advantage of this. And then finally, I think that as we look forward, we're going to enter the area of what some people have called ambient computing or ubiquitous computing, where everywhere you go, there's some degree of intelligence, and that intelligence is interacting with cloud services, either in sensor form or some other form, so that the amount of information available is going to be just enormous relative to what's available today. And we're going to have sort of the continued digitization of everything, which will lead to the ability to sort of, through the evolution of the semantic web, for people to be able to find information much more easily, for being able to mash together applications in creative ways that we can't even imagine right now. I'm really looking forward to the next 4 or 5 years, I have to tell you.
Sounds like it. How do you see AMD fitting in, as far as, specifically, how does AMD?
So we obviously have the most aggressive roadmap in terms of heterogeneous compute that's out there. It's richer than any other announced roadmap. Our sort of performance, power efficiencies are going to be better than pretty much anyone else's. I mean, by the time you hit, say, 2017, you can expect sort of on the order of 50 gigaflops for 1 watt. And in terms of performance, it's going to be amazing. The levels of memory bandwidth that we'll be able to support, given sort of interposer and stacking technologies, will be tremendous. We'll be able to drive huge amounts of vector compute at that point. So I think that's an area where essentially I expect that we'll be dominant. If you look at some other places, we're going to bring in, I think, tools and platforms that take advantage of the level of aggregation that the massive data centers are offering. They don't buy a couple of servers at one point. They buy, containers of servers, racks and racks of servers, and offering ways to, disaggregate I/O in interesting ways will allow both CapEx reduction as well as OpEx efficiencies, and make it substantially more power efficient. And lastly, I think that we're going to extend heterogeneous compute into a number of other areas. People want performance increases year over year. We're coming to the end of the core wars for sort of power envelope concerns. There's going to be sort of a next turn where heterogeneous compute isn't just GPU. It might be networking, it might be security, it might be analytics acceleration, etc. And those pieces will be on die next to the x86 core. They'll be caching agents. They'll be able to live in the same virtual memory space as the applications that use them, etc. And it'll be a sort of a performance uptick, efficiency increases, and I think that we're going to play a key role there, if not a dominant role.
Beautiful. Well, that being said, I suppose this following question won't come as much of a surprise. In the x86 world, AMD plays the David to Intel's Goliath.
Yes,
That's
yes.
how it's portrayed quite often. How is it that you see it, not only now, but in the future as well?
Well, certainly right now we are the David, though I do want to remind you of the ending of that story. It didn't work out well for one of the parties concerned. Not to draw too many lessons from that, I do think that we are going to. So there are a variety of things that led to this point. If you look back in 2005, our market share was close to 30%. And we were really first to market with an understanding that performance, power efficiencies were a critical ingredient in how a data center considered their purchase of server nodes. Looking to the future, I think that we're going to have an opportunity both at the platform level and at the server node level with things such as heterogeneous compute to have that same kind of splash. So I do expect, we're going to do substantially better going forward. I'm hesitant to give percentages or anything like that. That's not really my place to do. But I feel like we have lots of room to grow, and I think that our technology supports that.